Hello and welcome back to Higher Maths, Polynomials and Quadratics. In this lesson we are going to look at finding unknown coefficients. So if we have a polynomial such as x cubed plus 2px squared minus px plus 4, where p is a constant, we are going to be looking at how to find the value of p. So if we divide the polynomial by x minus h, then we will obtain an expression for the remainder in terms of the unknown constants. If we already know the value of the remainder, we can solve for the unknown constants. So let's have a look at how we go about doing that. So example number 1 here, given that x minus 3 is a factor. Now remember guys, if x minus 3 is a factor, then x equals 3 is a root. So we can use synthetic division with 3, and we are going to get a remainder of 0 if x equals 3 is a root. So I'm just going to set up my synthetic division table as normal. So 1 minus 1, we have plus px here, so it'll be p there, and then plus 24. So bring the number down, multiply it by the front, put it in there, add them together, to get 2, multiply by 3, 6. Now what is p plus 6? P plus 6 is p plus 6. Multiplied by 3, remember to multiply both of these terms by 3, not just the p. So it's 3p's plus 3 6's, which is 3p plus 18. So 24 plus 3p plus 18 would be 3p plus 42. And we know that equals 0 because we know the remainder should be 0 because x minus 3 is a factor and x equals 3 is a root. So 3p equals negative 42, p equals negative 14. And that's us done. We found the value of p. Now what we could do from there, if asked to, which we're not asked to do in this question, we could substitute in for p. Negative 14 plus 6 is negative 8. So we'd end up with x squared plus 2x minus 8 here. So we could actually fully factorize the cubic after we've found the value of p, just by substituting the value of p into the quotient here. All right, this one we're given 2 bits of information. So when f of x is divided by x minus 2, the remainder is 6, and x minus 1 is a factor of f of x. So this time we have px cubed plus qx squared minus 17x plus 4q. So set up the synthetic division table the same way as always. So px cubed, qx squared minus 17x plus 4q. So there's the 4 terms in the top row of our synthetic division table. Now after this, we just need to be really, really careful. So bring the first term down, multiply it by 2 is 2p, add q, multiply all of this by 2, which is 4p plus 2q, add it to negative 17, so 4p plus 2q minus 17. Again, multiply every term by 2, and then add on the 4q, and the remainder is 6 when we divide by x minus 2. So 8p plus 8q minus 34 equals 6. Add 34 to both sides, so 8p plus 8q is 40. Now looking at that, we can actually divide every single term by 8 just to make p plus q equals 5. So that is our first equation. And x minus 1 is a factor, so x equals 1 is a root. So again, same terms in the synthetic division table. Bring it down, multiply by the front, which is just 1. Keep on going, and we end up with p plus 5q minus 17 equals 0. And then add 17 to both sides. So what we have is a pair of simultaneous equations here. So we have p and p. So if I do equation 2 subtract equation 1, so I do label them and I say what I'm doing to them here. So then 4q equals 12 and q equals 3. And if p at q equals 5 and we know q is 3, just by inspection, just by having a look, p equals 2. Okay, so what have we done there? We have just repeated our synthetic division process, but at the end, because we know x equals 3 is a root, we know this will equal 0, so we can solve for p. And in the second question, we have a pair of equations in p and q, so we use our National 5 simultaneous equation knowledge to solve to find the values of p and q.